In this video, we're going to go through the frequency of the first harmonic. Now, this is only in some specifications. I know it's definitely in the AQA specification of circular motion or simple harmonic motion. So do have a check if it's in your specification. If it is, it's an equation that's very rarely used actually. So I'm just going to quickly write this equation out. F equals 1 over 2 times the length of a string multiplied by the square root of the tension of the string divided by the mass per unit length of the string. Let's have a look at how we can use it in this question. It's told you the frequency of the first harmonic is 300 Hertz, but the tension is now doubled. It's asking you what's the frequency after this change. Well, let's first pick out what variables are changing and which ones are staying the same. Well, if it's tension that's being doubled, tension is changing, causing a change in frequency. What about the other variables? Well, length is actually staying the same. We're still using the same length of wire. Because it is the same material of wire, the mass per unit length is also the same. We now think to ourselves, okay, how does frequency relate to tension in this case? In this case, we say frequency is proportional to the root of the tension. Now, if you think back to GCSE maths, you might remember that we can write this out as frequency. Let me just zoom in a little bit. Is equal to a constant multiplied by the square root of tension. If we divide both sides by the square root of tension, that means that the frequency over the square root of tension is always the same. So that's always going to be the same ratio. We can now form our own expression. We can say that the initial frequency divided by the initial tension that it had, or the square root of the initial tension that it had, is equal to the frequency afterwards divided by the square root of the tension that it had afterwards. Our goal is to find the frequency of the first harmonic after the change, which is essentially F2. So let's rearrange to make this the subject. We can multiply both sides by the square root of T2, and we get that is equal to F1 over the square root of T1 multiplied by the square root of T2. Let's now think about the changes that are happening. Well, it says the initial frequency is 300 Hertz. So I'm just going to quickly change to a different color. And we can write that F1 is 300 Hertz. It says the tension in the wire is doubled. So if it's doubled, that means that the tension afterwards is like 2 times the initial tension. So I'm just going to write this T2 as like 2 lots of T1. We can manipulate this a little further. So we have 300 multiplied by, I'm going to separate this into two separate surds. So the square root of 2 multiplied by the square root of T1. We're able to do that because there's a rule with surds that root A times root B is equal to root AB. So I reverse this. I said that the root of T2T1 is equal to root 2 times root T1. We then divide all of that by root T1. We can then cancel out root T1 from both sides, from top and bottom, and we're left with 300 times root 2. And 300 multiplied by root 2, I believe it's 420, meaning your answer to this question is just 420. And that's it, that's everything for this question. So again, a very ultra specific question, but be sure to leave a like if this video did help and subscribe. I'd appreciate it a lot. Thanks for watching.